So we've got Analyst Rick Sherman from Athena IT Solutions, one of my favorite analysts in the business. He's one of the busiest guys out there. He's almost always on a client site, so that means he's got his hands and feet involved in stuff, boots on the ground, as they call it. He's actually out there implementing solutions, so he brings a lot of really good granular perspective about what's happening in the business world. We've also got our very own Robin Bloor, Chief Analyst here at the Bloor Group, and we're pleased to have Lawrence Reber, Big Data Product Marketing and Strategy over at IBM. I've known Larry for a few years now as well. Folks, these people really know their stuff, so I'm very pleased to have all of them online today. So with that, I'm going to hand it over to Rick Sherman, and yes, in just a moment I'll post a link to the slides, folks, so watch that chat window for that. And with that, Rick Sherman, I'm going to hand you the slides. Just click anywhere on that slide and use the down arrow on your keyboard, and the floor is yours.
Thanks, Eric. So what I'm going to try to do is start off this conversation and talk a little bit about what we're dealing with and what we're talking about customers and prospects as far as how they're implementing or what they're planning to do on the Hadoop side and on big data. So I'm going to really take it from an implementation point of view. And I think this will then lead into the differences and the changes in the technology platforms that are happening today. Now, the biggest thing that's happening, even though Hadoop and a lot of the big data technology came off and was created in Yahoo and some of the big retail vendors out there, search engine vendors, to a large extent, the open source nature of this meant that people really weren't familiar with what the technology was. And the technology coming out of the open source side, usually, even though it may be powerful, it really isn't considered sort of for prime time only or not considered mature, at least for the folks that aren't usually used to using open source software. But Hadoop and the NoSQL tools have really evolved over the last couple of years, especially from a set of discrete tools to overall platforms. Some of that movement to the platforms have been because of system integrators, because of the tech titans like IBM that have joined in the movement and realized and embraced the movement. So that's been very exciting. And it's meant that it's more available and accessible to customers trying to implement big data. Now, a few of the other advancements that have happened is one is cloud deployments or platform as a service has really taken off in this space. Now, obviously cloud is another one of these hot topics that we talk about all the time with folks. But one of the areas where it's particularly important in the big data area is that in many areas, you might have a lot of legacy applications. With big data, most people are starting off from a green field, from scratch. So there's an opportunity to look at, should we deploy this on-premise or in the cloud? But second, and probably more important, as we'll get through in the next couple of slides, is the need for people to ramp up in the technology, to get the skills, to deploy the infrastructure to do big data. None of those are trivial tasks. They're all large tasks to sort of get ramped up. Platform as a service, the cloud deployments provide the opportunity for people to get into the space much more quickly and start getting business value out of there. So I think cloud deployments is one of the key areas that people are going to need and going to use in this space. Third, as with most new technologies and new technology waves, usually the first wave gets implemented and it becomes a data silo or an application silo. That indeed was the case with some of the initial implementations in big data. So you see a lot of the vendors, both open source as well as some of the larger vendors out there, have moved their data integration tools, their data integration suites, in order to work with Hadoop, with Hive, and with MapReduce, et cetera. So it's pretty exciting that people can, when they need to, interplay both big data with structured data and get even more value out of it. And the fourth area where the platforms have been advancing is advanced analytics. And there are many, many analytical tools out there and advanced analytic tools such as data visualization tools out that people have been using on the business intelligence side for a while. Now those are being able to be extended and being able to expand the capabilities people have on the big data side. So what sort of the benefits of this is that we're getting increased capabilities and reduced programming. Now there's an awful lot of manual coding involved on the big data side, and you'll see as as both Robin and IBM will talk, the capabilities have been put into these platforms are reducing the need for programming and improving and lowering the cost and improving the time to market. In addition, there's a shifting of roles. Since we had traditionally IT been in charge of sort of doing data warehousing and business intelligence, you'll see now a lot more integration with business folks, business people as far as implementation, because they understand what they're trying to do and the big data side and how the data can be used. We have a role of data scientists and business analysts, which I'll talk to in a second, and we also have a large amount of services being implemented in this particular space. Now, there's anywhere you read about labor and skills in the big data side, you'll see big proclamations that there's a very big shortage of data scientists and people that can do development in this space. Now, that's sort of true, but what's happening is that's changing, and I also think that the roles that are happening in the skill areas are also changing. Now, first off, data scientists are vastly misunderstood. If somebody tells you that they can increase, and I've read this even in some analyst firms that I think are quite understanding of what's going on in the space, they still reduce down a data scientist as somebody who's coding Java or Python, and that's not simply the case. A data scientist is someone who understands the business, probably understands statistics. The problem with what that role has been in the past has been because of the state of the tools, they've had to spend an awful lot of time programming in those particular tools. But their expertise isn't programming. Their expertise is being able to develop predictive models, which is a very sophisticated kind of skill set. People who are economists, psychologists, et cetera, with those kind of backgrounds, sometimes are better data scientists than a computer science person. In fact, one of the chief analytical officers that I know that I've known for more than a decade and has worked in a couple large software as a service firms, has a PhD in psychology. So it's not a programmer, but it's somebody who can understand what the models mean. Many of these models have over 1,000 variables in them, so it isn't really a programmer. It's somebody who understands the business, or econometrics, or group psychology when they're trying to predict behavior of customers. Second area is big data programmers themselves. A lot of emphasis, again, on programming, but as the tools go to a platform, as more and more of the applications are automated, as you'll see more and more services being data services and application services being developed and put into the big data and Hadoop platforms, the need to code everything is being reduced. This is similar to what happened on the data warehousing business intelligence side, where everything was coded at first, then we got data integration and BI tools. This is the same kind of wave of maturity that's happening in big data. And finally, business analysts. You'll hear that the need for data scientists is being reduced because we can develop stats programs or applications. What's happening is I think there is a confusion in the marketplace. There's only a certain amount of people that need to be data scientists. What's happening is that the tools that are being deployed, particularly the analytical and integration tools, are making it now that business analysts can actually take the data, analyze the data through things like visualization tools, and be able to, and data discovery tools, and actually be able to make use and make decisions based on that data. And finally, the other thing that happens usually with technology waves is that we always have this sort of one-size-fit-all. We had data warehouses and relational databases, and people figure they can handle anything that comes at them. We got unstructured data, which never really fit, never did well into that structure at all. So then we had Hadoop, NoSQL databases out there, technologies. People started putting stuff into that, and then they decided, well, everything should go into a Hadoop platform. Now, I know we have Hive and other things, but the reality is that there's a variety of data. Some data needs to go into Hadoop and NoSQL and big data technology platforms. Some data will probably stay in traditional relational databases. So we need to be able to look at where that is. The second area is that we also want to transition in data warehousing and enterprise relationship products, ERPs, that there's a difference between data capture and analytics themselves. And that's another area where people are starting to mature and realize that there's capturing of things, and then there's analyzing the data itself. So one of the things that the last sort of ideas that I give is that big data and big data planning, that big data is all about the business. Over half the time, according to one of the Forrester studies that I just read, people do big data analysis and they don't do any planning for what the business needs. So figure out what your business needs. Second off, realize that it's more than just text analytics. You need to be able to provide a variety of advanced analytics in the space. And finally, that there needs to be data awareness on the NoSQL side and Hadoop side. You're looking at how much data can we get in, how current can the data be. When you're dealing with traditional structured data, you're dealing with comprehensive data, but you're also looking at consistent and clean data too. So that's a cultural shift for IT, and you have to realize when it's appropriate to have one or the other, and then when do you mix them.